So this topic is on Module 4, Exploring Distributions, Topic 10, Scientific Notation. This is a very short video just about addition with limited accuracy. And the whole scientific notation topic is covered in the workbook beginning on page 101. And what I'm going to do today is I want to just do a few calculations on paper just to show you how to handle the arithmetic with numbers that come from measurements. So in an algebra class, if you have, say, 2.4 plus 2.31, it is assumed that the numbers are perfectly accurate, that it's really 2.4000 forever and 1.31000 forever, so that when you add them, you know how regular addition works. You get 3.71, and that's the end of the story. Okay, but suppose these numbers were not like coming from an algebra problem, but were measured in a laboratory, and you had 2.4 meters, and then you had 1.31 meters. In measurements, if you only wrote 2.4, it's because you don't know the rest of the digits. It's not that they were all zero. And so the problem is really more like 2.4 question mark, question mark, question mark, plus 1.31 question mark. And so when you add those together, see the last place where you have a number here, the hundredths place in the 1.31, it gets added to a question mark in the 2.4. We don't know what goes in the hundredths place there. And so after we finish adding, we still don't know what's in the hundredths place in the sum. And so the standard thing to do is to, you would keep the 3.71 internally in your calculator or on your spreadsheet. If you're going to use it in later calculations, you would keep all the digits, including the ones you're not totally sure about. But when you get around to reporting a final result, you should really only say 3.7. You should not say 3.71 because you don't really know that that 1 is correct. And scientific notation doesn't change much about this. If you had 1.2 times 10 to the third, and then you're adding 2.34 times 10 to the third meters, when you finish adding them together, at first you get 3.54 times 10 to the third meters. Instead of saying times 10 to the third meters, I could just say kilometers, same thing. 3.54 kilometers, but the 4 is not known to be the truth because we don't know the second digit. After 1.2, we don't know the next digit in that top number in the sum. So we only should report for a final result about 3.5 times 10 to the third meters. Okay, now what if you're adding numbers and they start out with a different exponent? See this top number in problem 2, it's times 10 squared meters, or 4.5 hectometers. And the 1.123, that has a different exponent. That's times 10 to the third meters. So before I add those together, I have to get the units the same. You see, right now I'm adding hectometers plus kilometers, but I need to make it all kilometers. So I go to the bigger power. The 3 is a bigger exponent than the 2. And so I take the 4.5 hectometers and I turn it into 0.45 kilometers. And how you do that conversion is illustrated in another video. And really, you might want to look at the other video first. It's a Khan Academy video that I've linked in our Canvas website that starts with scientific notation from the very beginning. Maybe I'll just show you briefly here as well, because that video is a little bit long and it might be more, you might already be familiar with much of it. But so I'm just going to illustrate converting the 4.5 times 10 to the third into whatever it needs to be. I'm sorry, 4.5 times 10 squared into whatever it needs to be times 10 to the third. So what I'm going to do with my 10 squared is I'm going to multiply it by 10 to make it 10 cubed. But now if I've multiplied and made the whole thing 10 times bigger, I need to divide. I need to multiply by 10 to the negative 1. Because the 10 to the minus 1 times 10 to the first there in the middle, 1/10 times 10 cancel each other out. So I've not changed anything. And so if I take the 10 to the first times 10 squared on the end, I get the 10 cubed that I'm looking for. And if I take 4.5 times 10 to the negative 1, or 1/10, that just turns into 0.45. So that's how I got from my original problem to this second one where the units are kilometers both places. And then I just complete the problem there. And at that point I can see that the 3 on the end, after I've added, I at first get 1.573, but I know that the 3 is uncertain. And so when I get around to reporting a final answer, I wouldn't know what's in the thousandths place. And so I would report 1.57 times 10 to the third meters. I have one more example that just presents a challenge with carrying, and then that's it. So I'm going to add 9.5 times 10 squared plus 9.7 times 10 cubed. And first I need to change them both into 10 cubes. So let me do that. And now I can add them both together. And I get 10.65 times 10 cubed. But the 5 at the end is uncertain because I did not know what's in the hundredths place in the 9.7 times 10 cubed. So for my final answer, I report just approximately 10.7 times 10 cubed. I round to the 10th place because what's in the hundredths place is unknown, but well, it's at least 0.5, so it's going to round up. So you use whatever you have there for the rounding. Okay, that's all for this topic.